This is your pastor. This is your favorite math teacher, DKE. And today's lesson, we are going to look at sequence and series. Sequence and series. So, first of all, we are going to look at the definition for what? Sequence and series. And you know, and also go into details and solve questions and know the types as well. So, without wasting more time, let's think what is sequence? What is sequence? So, sequence. Sequence is what? A set of what? Numbers written in order with a specific what rules or formulas. And I will explain. So let's also look at series. What is series? So let's say sequence. So this is sequence. When the things are, we have numbers or values which goes with let's say even numbers.
Yeah.
So let's take something like even numbers. So for example, even number we have 2, 4, 6. So when you say something is sequence, it follows the pattern. It has a rule. So let's see. So we have to, before you get to 4, we have to do something to the first value before you get to this side. So we added some value which is 2. So we added 2 to this before getting to here, which is 2 plus 3 gives us 4. From 4 we also move to 6. What happens to the 4 before we got the value 6? We added 2 to this 4 before we got the 6. So we can also determine the next number by also adding 2 to this 6, which is what? 8. Then in order. So that's called sequence. The thing follows in order. It also follows what? A certain pattern. So we have a certain constant value that we have been adding to each value to get the preceding what? Value. So let's look at series. So series is when these numbers are added. So as soon as we add an operation sign to these values, now it becomes what? A series. So for instance, for a set of even numbers like this, so as soon as we introduce an addition sign, it becomes what? A series. So let's say 2 plus what? 4 plus 6 plus 8. So this becomes what? A series. Now under that, we also have 2 types of series. So we have 2 types of series. So one we have finite series and 2 infinite series. So what does it mean by saying this series is a finite series or infinite? Now for instance, as I said, whenever you introduce a plus sign, this is an operation sign to a set of numbers, it becomes a series. Now we have 2 plus 4, let's take the even numbers that we have here, plus 6 plus 8. Then we ended. You have ended. Are you okay? So they said maybe a set of even numbers ranging from what 2 to what 8. We have given a specific what range. So we have ended that this is because of a finite what series. Now for the infinite one, meaning it does not end. So we are using the infinite series example. So the infinite series, as they say, let's take the same thing as example. So you have 2 plus 4 plus 6 and 6 plus then the group continuation, meaning you can add and add and add without what ending. So infinite series is when we add a set of values with a specific without ending, or that has no ends. That's called infinite. But with the finite one, when you add a certain series or a certain numbers and you end at a certain point, it's called what? Finite. That's called what? Finite. So let's go into details. Let's look at the types of sequence and series we have. So we have 2 types of sequence and series. 2 types of sequence and series. We have 2 types of sequence and series. So one, we have the arithmetic or arithmetical progression. This is also known as linear sequence. It's also known as linear sequence. And we also have what we call geometric progression or geometrical progression. So these are the 2 main types of sequence and series that we have. So we have the arithmetic progression in other books, which we see what linear what sequence, and we also have the geometrical what progression. In short, we say this one is called AP and this one is called GP. Now let's also go into details. Let's take it one after the other and then this into details. So let's take arithmetic progression, for instance. Let's take arithmetic progression. With the arithmetical progression, let's define, it's also known as we said, it's also known as what? Linear what? Sequence. This is where we have a series of numbers where any term or any number or any value differs from the preceding value by a certain constant value called a common difference. So when you have it's a sequence in which any of the terms characteristic is what? A sequence in which any of the terms differ from the preceding value with a constant value called what? A common what? Difference. Let me explain it to you. This is how the explanation goes. So let's use the same example we use when we have the examples of even number. So for instance, the examples of even numbers. So where we have 2. Let's say 2, we have 4, we have 6, we have 8, we have 10, in that order. Now let's see. It says, it's a sequence in which any of the terms differ from the preceding. So we have 2. The preceding value here is what? 4. We have also 4. The preceding value of this 4 is what? 6. So in that order, they said, where any of the terms differ from the preceding value by a constant value. So that value does not change at any point in time. It runs through. So let's see. From 4, you jump to what? From 2, you jump to what? 4. What happened to the 2 before you got to 4? We added a certain constant value. Are you able to see it like this? We have these 2, and we added a certain value to it, and we got what? 4. Are you okay? So it becomes x equal to 4 minus what? 2. So where therefore x is equal to what? 2. So this is telling us that from A, if you take any 2 of these values, the difference between these 2 values is what? 2. So for instance, if you add 2 to these 2, you get 4. If you add 2 to this one, you get what? 6. If you add 2 to this 6, you get what? 8. That's so forth and so forth and so forth. So this value that I'm putting over here, this 2 is called a common difference. Common difference. It's called a common difference. Why? Because this particular 2 here is common to each of any of the 2 terms. Because you see this value here differs from the preceding value by what? 2. This value also is what? Differs by the preceding value by what? 2. So you see that this 2 is running through any 2 values that you pick. So it's called what? A common difference. This here is common to both sides or throughout. So it's called a common difference. Now, assuming you have been asked to write the nth term of an even number, they said you should write the nth term of an even numbers. So they said you should list every even number that you know. You will list and list and list, and you will never end. So if you want to find the end of any given values, this is how it goes. So assuming we have example, let's take the same examples. Even numbers when you have 2, 4, 6, 8, 10, and so forth and so forth. Or let's put it in form of series. We count 2 plus 4 plus 8, 6 plus 8 plus 10 plus a certain value. Because we can list all the even numbers we do, and we will never get to their end. So let us assume they said we should find the nth term of every even number that we know. And they give us maybe 2 years, and we can never finish writing every even number that we know. So what we do is that in sequence and series, the first value that is given is called the first term. It's like a movie that we know that is called a series movie. When they are starting, they always start with maybe series 1. And even that series 1, they have also episode 1, meaning they have a starting point, they have a starting value. Are you okay? So anything you do, you have a starting point. So that's why if we are to start listing an even numbers, the first even number that you know is what? 2. So this value here is called first term. First term. Then the difference between any of these two values, that range that we have found to 2 is called the common difference. So the difference between these two and the first two, which is 4 minus 2, which is called 2. Then you also have 6 minus 4, which is called, if you subtract the 4 from the 6, we also get 2. If you take these two values to 8 minus 6, we are still getting 2. So you see that the difference between any of these two values will give you what? 2. So these two becomes our what? Our common what? Difference. So this becomes our common difference. Now, assuming we are to write the nth term of every sequence, so we always have every series or sequence has a first term. We also have a common difference under AP. So we discuss the first term plus. Then if they say we should, what is the nth term for an even number? And we can't determine the nth term of even number. You can list and you can never get to the end. So we normally represent the nth term by n. So that's n minus 1. That's we assume that every value starts from 1, or values of every counting number starts from what? 1. So when you say counting number, there are numbers that start from 1 to what? Infinity. So you subtract 1 from it. Then we multiply the whole thing by the what? Common difference. So the nth term, which we don't know, we represent it by what? U of what? It is called nth term. What is our use? N like this. Nth term equal to this. So the first term plus n minus 1 times the common difference. So let's assume they say we should write, we have this, they say we should find the nth term of this, of an even number, the nth term of an even number, because we can never tell the last term of an even number. Then you have to write in the form of this. So, but we know the first term of what every even number, which is what? 2. So then we write our 2 there plus n. Because the n is the last term that they say we should do for, and we don't should. So we have to maintain what? The n there. So n minus 1. But we were able to determine the difference that is running through every 2 consecutive terms. So this was what? 2. We multiply it by 2. Then we are going to have 2 plus, therefore, we have to expand the bracket over here. You have to expand the brackets. So this is going to be 2n minus 2. Then, as you can see, you have positive 2, you have negative 2 here. Then you can cancel it out. Therefore, the nth term of every even number is what? 2n. So, let's assume, let's take this. We have the first term to be an even number, which we have here is 2. So assuming they say we should find the 10th term of an even number, it's just a matter of what? Putting these two, then we have been specified with the even number, the 10th term, that you should find that what is that number. So just put that number, this 3 here. So which is going to what? 3. So 2 times what? 3 will give us what? 6. Now let's come back. The first term here is what? 2. The second term here is what? 4. The third term here what? Is 6. So as you can see, we have gotten that 6 over here. Let us also do that if you have determined maybe the fifth term of this even number. So this means the fifth term. And this fifth here is the end that they are asking us to what? Find. So for instance, this is going to be 2 times what? The 5. So 2 times 5 is going to give us what? 10. So let's go to the even number. So when we are listening, so if you have let's count. And the fifth value is what value? So you have 1, 2, 3, 4, 5. So you see that the fifth term here, we are still getting the same one value. This is what? 10. So that's about determining the nth term of a certain value. So let's look at the situation. So this is an even number. So let's determine them. When we are asked to find the nth term of, let's say, an odd numbers. So let's take odd numbers for instance. So let's say we have, let's take this one to be example 2. To find the nth term of so we have this, they said we should find the nth term of when we have the series of 1 plus 3 plus 5 plus 7 in that order. If you are to find this, let's see. So let's find this. If you are to find this, let's see. So with this, always we need to determine the first term. So what's the first value here? So the first value is your first term. So this is our first term. Now we have to look for the common difference. We need to look for the common difference. Let's look out for the common difference. So the common difference, we take any of these two values. So either you take this value and you take the preceding value, or you take this and you take the preceding value, or you take the first one and its preceding value. Then you find the common difference. So for instance, let's take these two values. It's going to be 7 minus this. Okay, so this is going to give us what? 2. Or you take this and its preceding what? Value. So this is what? 5 minus what? 2. Sorry, 3. This is also giving us what? 2. So if we take any of this value and its preceding number and you find the difference, you still have to get the same what? Common difference. So at the end of the day, this becomes our common difference. So which is mostly represented by D, the letter D, small d. Normally we represent it by letter D. So now let's write the nth term. So the nth term now becomes the first term plus the nth term that you don't know minus 1 times the common difference. So we know the first term, which is what? 1. Plus nth term, which is n minus 1 times 2. So which marks on 2? 1. Then we expand the brackets. Therefore, we are going to get 2n minus 2. Therefore, you can also perform an algebraic simplification over here. You can perform an algebraic simplification over here. So we have positive 1, negative 2. Therefore, we are going to have 2n, then minus 1. So therefore the f term is what? 2n. And in normal sense, way back here, you see, if we give you a certain value, they ask you to find the rules for that value. So you sometimes even domain and its codomain, and you'll be asked to find the rules. That's when we have advanced and we are saying what we call sequence and series. So this becomes the rule for this sequence here. So we can use this rule here or this f term to determine the next value. So if you want to determine, so let's assume the solution. So 1, 2, 3, 4. So that you can determine the p value. So let us determine the p value. So the p value here is the n that you have got your value. So this is going to be 2 multiplied by 5 minus 1. Therefore, we are going to have 2 times 10. By expanding the bracket, we are going to get what? 10 minus 1, which is given us of 9. So as you can see, the next value is what? 9. Or as simple as that, you can add 2 to the what? This value and you still get your 9. So that's in the outcome that you can determine the 15 term. So which is what? 2, then you put your 15 there. Minus 1. So if you expand this bracket, you are going to get 30 minus 1. So which is going to give us 29. So let's try one example and see. So let's take that one to be example 3. So let's take that one to be example 3. One more example. So that one will be an example 3. So let's write one example over here. So find now we have been asked to find the 8th term of a linear sequence of the form when we have this sequence or when we have this series. So it's not a series, but it's rather a sequence because series have basically introduced an addition sign. So this was a sequence. So you first need to determine your first term. You need to determine your first term. You also need to determine your common difference. So from here, our first term is the first value. So the first term here, A, is what? 47. Your common difference, which is represented by B, is equal to what? So you always take the first term, then you subtract it from the preceding value. Or you take this, you subtract it from the preceding value. So it's going to be, somebody can take this, so which is 32 minus 37, which is going to give us negative 5. Or you can take the first two, which is 42 minus 47. It's going to give us negative 5. Or you can take this one. You still have to get the same value. So from here, we are able to tell that A is equal to 47 and B is equal to negative 5. From here, we can write our f term. Therefore, our f term is equal to the first term plus into bracket n minus 1 times d. So what is the first term, which is what? 47 plus n minus 1 times d, by this was negative 5. So let's simplify. So it's going to be 47 plus, then you can expand the bracket. So you multiply this negative by n, so I'm going to have negative 5n. Negative 5 times negative 1, I'm going to have positive 5. So therefore the f then is equal to now negative 5n. Then this plus this will give us 52. 47 times 5 will give us 52. So from here, now the person said we should find the what? The eighth term. Now this n has been specified. He said we should find this n. So therefore, if you have to find the eighth term, now if you compare this to this, you can see that n is equal to what? 8. N is equal to 8, therefore we are going to have negative 5 multiplied by 8 plus 52. So negative 5 times 8 will give us what? 40, negative 40 plus 52. So if we add these two values, we are going to get what? 12. Therefore, the 8 then is equal to 12. So that's it. So this is the situation when you have one, you have to find only one term. Now we are going to look at the situation when you have a sequence and we have to form two equations from it. So forming two equations. So for instance, let's look at the situation where we have a sequence which contains more than 2 terms. So this is where we have only one term to find. So we are going to look at the situation where we have 2 terms to find. So for instance, let's take an example. Let me just explain to you. So let's take example 1. So that is forming a linear equation using maybe simultaneous equation. So let's see, when we have example lesson 1, we have find the linear sequence whose eighth term is 38 and 22nd term is 1 each. So as you can see, this is the situation. This question consists of 2 terms and you have been specified. So let's see. First, we need what? It gives. So if you take this one, let's write the 8th term. So for the 8th term is going to be the first term. As we know, for this question, we are not giving the sequence. So the first term will still be A. Then n, by this one we have been giving n. This is what? 8 minus 1 times what? The common difference. Because you don't have sequence, we can't determine the common difference. So we still have to maintain our d. And they said this 8th term is what? get 8. Therefore, this will have to what? Equal to what? 38. So we are going to have A plus, so if you subtract this, it's going to be what? 7. 7 times D will give you what? 7D. This is what? 38. Now this becomes one equation because you don't know A and you don't know what D. So we need to leave it what? The way it is. Now let's move to the second part. They said the 22nd term. And you know that the 22nd term will also be equal to what? It will map to what? The first term which we don't know plus now we have been given the F there. So this is 22 minus 1 times what? D. So it's going to be therefore A plus 21D, which is what? What? 108. So therefore this becomes equation 2. So this is arithmetic progression which involves two terms by forming simultaneous equation from it. So when we have two terms, as long as we are going to resolve it in a simultaneous equation form, then solve it simultaneously by using up the simultaneous method that we do to simplify. So now we have gotten two equations. We now have equation 1, which is A plus 7D equal to 38 as equation 1. So we have equation 1 here, and we have the equation 2. So we are now going to solve this based on any method that you think it is applicable for you. Using what? Simultaneous equation, either by elimination method, or by substitution method, or by graphical method. You can even use metrics to solve this. So you have so many ways you can solve this. So let's use the elimination method. So the elimination method, I know you can visit my previous video on simultaneous equation, or how to solve simultaneous equation to revise. So using the simultaneous equation, maybe let's subtract equation 1 from equation 2. So if you have to subtract equation 1 from equation 2, A will subtract from A will vanish. Then we are going to subtract 7D from 21D. We are going to have 14D. This is equal. Then we are going to subtract 38 from 108. I think we are going to have 70. So we check what test which value that can go through again. So let's divide those by maybe 7. 7 is applicable to every. So 7 to 7, 7 to 14. 2. 7 to 7, 1, 7 to 70. 10 times. So we are going to have 2D 10. You can still reduce this by dividing those by 2, also by 2. Therefore we have D equal to 5. Now once we have gotten our D to be equal to 5, now you can substitute this D into any of the equations to find for A. You can substitute for this D to any of the equations. So let's say put D equal to 5 into equation maybe 2 or anything. So let's see equation 2. You can as well as put equation 1 and solve for the first term. So let's say we are going to have A plus 7 multiplied by what? D. Wherever you see you put what the 5. So multiplied by 5 equals to what? 38. Yep. So we are going to have A plus, so 7 times 5 give us 35 equals to what? 38. We are looking for D, A, so we make what? A the subject by look like index. So it's going to be A equals to 38 minus 35. Therefore A is equal to 5. 3, sorry. So we have gotten our first term to be 8, and then the common difference to be 5. Now the question says we should find what? So the person says we should find the linear sequence. Use us. Term is this. So now we are now going to write the nth term for this. So therefore the nth term is a plus n minus 1 times b. So with this, you know the first term, which is 3, plus n. This n don't know. So you still have to maintain n. Subtract 1 from it. Multiply the multiply by common difference. This is what? 5. So you are going to have 3 plus this gives us 5n minus 5. So therefore you are going to have 5n minus 2. And that is it. Let's take one more example on it, and so let's solve one more example. So this is example 2. So we are going to look at example 2, and there is sequence exists involving simultaneous equation. So let's see. It says find the term. So they say find the term of a linear sequence whose second term is 28 and the 17th term is negative 2. So the person said we should find the term. So we know the term. So the term is going to be a plus. So as we do n minus 1 with the formula, we are going to have a plus 10 times with n for n is becomes what? The n becomes 10, which is 10 minus 1 times d. So this is going to be a plus 9d. This is the 10th term of this thing that they say we should wear what? Or we should find. Now with that, before we find it, you have to get what the first term and there was the common difference. Before you can determine the term for term. And they say we should find this term, whose second term. And you know, you can find this by resolving these terms into what? A simultaneous equation. So we know the second term. So the second term will be a plus, so using the formula, is equal to a plus 10 2 minus 1 times d. Now I'm going to have a plus d, and the cell is what? 28, which is equal to 28. This becomes our equation 1. And the 17th term is a plus, so when we are using this, you know that the 17 is our n. 17 minus 1 times D. So we have A plus 16D. In the set is what? Called negative 2. So this term our equation 2. So therefore, we are able to determine our first term and second term. So we need to resolve this by using simultaneous what? Equation. So as you know, we can use any of the simultaneous methods to solve this. So let's see, we can subtract equation 1 from equation. The first I subtracted equation 1 from equation 2. So now let's subtract equation 1. Let's subtract equation 2 rather from equation 2. Equation 2 from equation 1. So if you have to subtract equation 2 from equation 1, A minus A will go. And we are going to have 16D minus, we are going to subtract 16D from D. We are going to have negative 15D. So then we are going to subtract negative 2 from 28. So it's going to be negative, 28 minus what? 2. So we are going to have negative 15 equals to the negative 2 multiplied to negative 2, which will go on positive 2. So we are going to have 28 plus 2. So negative 15 equals to 30. So from here, you want D. So what you have to do is to break your divide most by the coefficient of the D. This is negative 15. So negative 15 divided by negative 15 equals to 30 divided by negative 15. So this one will cancel this, therefore D 15 to 7 32. Therefore this equals negative 2. Then we put, so put D equals to negative 2 into any of the equations. So let's put this into maybe equation 1. Equation 1. So therefore, let's put this D equals to negative 2 into equation 1. So we are going to have A minus 2 equals 28. So therefore, if you make A the standard, A is going to be 28 plus, because if this negative 2 cross A equal to 7, it becomes positive plus 2. Therefore, A becomes what? 30. Now, what the person was demanding us to do is to find the 10th term. And the 10th term is what? A plus 9D. So from here, we substitute the A and D back into it. So we are going to have A, which is the first term. So we have the 10th term, which was A plus 9D. So let's substitute A into the 10th term we have got, so which is 30 plus 9 times B, where B is what? Negative 2. You put negative 2 there. We're going to get 30. So 9 times negative 2 gives us negative 18. Therefore, our 10th term is going to be, we subtract 18 from 30, we are going to have 12. So this is our 10th term. So this is where we end our lesson. And next time we meet, we are going to look at the sum of GP and AP. That's arithmetic progression. So today we are able to talk about the sequence and series. We also look at the types of series and also look at all the types of sequence and series that we have. We also gone through to find the first term, how to find the first term in the common difference, substance of example. We also look at how to, when we have a question which comprises two terms and their end, how to deduce a simultaneous equation from it. We also find the first term in the common difference, and also use to find what you have been told or you have been asked to find. So this will end This is your favorite smart teacher, that's DKE. And you can subscribe to my channel, or you can visit my channel for more contents. And also subscribe for more information when my content is being uploaded so that you will notice. Thank you.